Hello again. This is just another question on our exam paper. So let's have a look. So the polynomial, our function here, is defined as this here. So we say find the remainder when it's divided by this number. There's two ways of doing this. Either we try and divide it and then add remainder. Oh, this is a bad color to use on that color. So we add our remainder here. Okay, this is a bad combination of colors. Add our remainder here, try and divide it. Takes ages. We'll get to the end and be like, heck, there must be an easier way. So what we say is, our remainder is x plus 2 equals 0. So we just say x equals minus 2. Oh, this is bad handwriting. X equals minus 2. And then let's plug it back into our equation. So we get minus 2 cubed minus 9 times minus 2 squared plus 7 times minus 2. You see what I'm getting at here? Plus 33 equals, you guessed it, our remainder. So then, ta-da, let's have a look. So this becomes minus 8. Next bit becomes minus 36. Then becomes minus 14 plus 33. And then those mathematicians amongst us, hopefully a lot of us, say, heck, that's just minus 25. Done. First part complete. 2 whole marks. There we go. That was pretty quick, wasn't it? Okay, there we go. Done. Okay then, so show that x minus 3 is a factor of f of x. Okay then, so it says it's show, so they've proven it for us. We just need to substitute in, don't we? So I'd say to you, this is pretty cool. So we've got our function here. Okay, we need to just prove, since when it's a root, you would say to me, x minus 3 times whatever, I would expect to get 0. So consequently, I would just say that x is 3, and I should get my function, so f of x, to become 0. Let's try that. Let's try that all the way up top. So it's 3 cubed plus, oh, okay, I'm finding this hard to do all this. I'm sorry, I'm new to this. Plus 7 times 3 plus 33, and I'm going to expand this all out. So that becomes 27, 9 times 9 minus 81 plus 21 plus 33. Add these all up, that becomes 54 plus 27. Hey, that's just 81. 81 minus 81 equals 0. Done. That's this whole section is the proof, not just the last bit. That would be a bit funny if you just wrote that down in your exam. So yeah, that's all the proof. Okay then, so we look at this now. We say to ourselves, what's the last part of this question? Here we have solve the equation. We need all the roots. So as you might know, cubics go something like this. 1, 2, 3. We've got one already. There we go. That's done. So we need the other 2 roots, and hopefully they don't give us imaginary roots and these are real roots, because if it was like this, you would say to me, but we just found the only one, and I'd say, yep, you have, but there's imaginary ones, and I don't need to speak about all of that yet. Later on. So I'll go way back. Sorry about the loud clicking. Okay then, since we know that x minus 3 is a root, yeah, I would say to you, x minus 3 is a root times a bunch of something equals our initial x cubed minus 9x squared plus 7x plus 33. Okay, let me move this down here. This is a bit messy. Then I say, heck, what times a linear times what gives you a cubic? And then some of you may say, hey, wait a second, as next term, so maybe it's ax squared plus, you see what I'm taking this? Plus bx plus c. Then you go, okay, let's go through this. And when you see it, you'll you'll be like, whoa, that's pretty cool. Or you'll realize, oh gosh, he's a sad person, why would he get so excited about such a simple thing? And then I say, it's because it's mathematics, and then probably get into a bit of a punch-up or something. So I'm just timing these out, and yeah, minus 3 times c is minus 3c. C is 3. And then you say to me, oh, wait a second, whatever comes in front here must come in front there. And subsequently, we're just equating coefficients now, aren't we? So we say A, we use a different color for our A. A is the same as 1, because there's a 1 in front. It's just anything times 1 is itself, so there's just 1 in front. Then the next color, I will use this, there we go, nice blue mauve color, or whatever you want to call it. B minus 3A here is what's in front here, so that becomes, okay, my pen is being a bit jammy, minus 9. Subsequently, another equation we will produce, C minus 3B. C minus 3B is 7. And then, last but not least, let's not forget about this, our friend at the end. Minus 3c is the same as 33. So minus 3c equals 33. Oh, a bit of a dark colour, but I like it. Okay then, so let's solve. Okay, then we know what a is. This is a nice one. And this we can rearrange to c being minus 11, divide minus 3 by both sides. And we know what a is, so that's the same as b plus, no, minus 3 equals minus 9. So add 3 to both sides, you get b equals minus 6. And you'll say, heck, I've got all of them. But then I say to you, you know what? Double check with our last equation. If our last equation works, then as a whole we're doing it right. So minus 11 minus 3 times minus 6 equals 7. So you'd say minus 11 still. Minus times a minus is a plus. And then 6 times 3 is 18. And then you could say, heck, 18 minus 11 equals 7. That kind of flows a bit. So then we link it back to our top bit here. And we say, okay, let's scroll down a little bit more. Okay then, so it becomes 1 x squared. B is minus 6. Yeah, I lost it there for a second. Okay. Oh, what am I doing? What am I doing? Oh dear. Minus 6x minus 11. You'll say to me, okay, let's think this is just a cubic. I can do this. And then you'll sit down and say, oh dear, we have to complete the square again, or do something, and you probably remember the formula now, but I could complete square, or I might just as well put it into the formula, b squared minus 4ac plus minus over 2a. Try and memorize this, it's very useful. You'll only use it for a while more, and then you'll memorize it, and then ta-da, you're done. Plus minus 36 plus 44. I could spend ages doing the algebra, but I think it's the concepts you need to understand more than anything else. And then this gives us 2 roots of 3 plus minus root 20. Wait a sec. Yeah, this works. And 3 plus minus 2 root 5. Okay, then let's have a look at our marks and see what they're allocated. Okay, there we go. We did the first step fine. Did the second step fine. And ta-da, they give us these here. And those are our other coordinates. Yeah, because it's plus minus. Okay. I'm happy with that. Are you happy? Hope you are. And if not, give me some feedback. And hope you enjoyed and that was helpful. So yeah, there you go. I will continue my conjunction of smiley face at the end of everything, and everyone will be happy. And he looks a bit sad and he's got a bit of a double chin. Okay, alright then guys, see you